Yeah.
Okay, guys. Before we begin, because the class normally only begins at 15 past, just a few announcements. The next class, so next Friday is about service-oriented architecture and enterprise service class, and luckily, and because of a stroke of luck, we actually have a visitor from the Software Engineering Institute from CMU, so Paulo, so he has the same name as I do, is going to be visiting us, and actually he will be doing, it's not a class because it's not going to be 2 hours, but it's going to be a seminar about service-oriented architecture and actually enterprise service class and so on. So the next class is only going to be about 1 hour, which is the seminar. And in terms of labs, the labs that will take place next week are only going to be the ones in the morning. So from 9 a.m. until 12 p.m. because during the afternoon we'll be showing Paulo around and so on. So please be here next time. I hope that we have a lot of audience. And the same thing applies to you guys at CMU, although you can actually talk with Paulo a lot more than we can.
So he actually lives in Brazil, so we don't get much of an opportunity either.
So he is in Brazil now?
Yeah.
Okay, I didn't know that. I thought that he was normally there, not in Brazil.
No, he still works for the SEI, just from a nicer location.
Okay, that's a good deal. Hopefully with a U.S. salary and not a Brazilian salary.
Yeah.
So that's the first announcement. Regarding last class, we were discussing basically validation of XML, and we discussed a little bit XML transformations. There were some small technicalities that I left out because of lack of time. Is there any questions regarding any of the material from last class? Have you already done the project, the whole project? It's done? Okay. At least one group in the 90 students taking the course has the project done. Okay, so the topic of today's class is Enterprise Application Integration in 2 hours, which seems a little bit of a challenge. But the idea is to give you at least a language or a framework to think about enterprise application integration and to give you an idea of some of the problems and some of the approaches that people take when actually they are doing enterprise application integration. And if you remember, basically, we started with this scenario, which was a scenario of enterprise application integration across organizations. So you were not talking about applications in one organization or across departments. We were talking about applications across organizations. And one of the first things that I would like to discuss is actually those arrows between the several institutions and the type of communication channels that exist when you are actually communicating across organizations. So a very kind of naive way of thinking about this would be, okay, if I need to make a purchase to Prentice Hall, basically I'm going to open a socket to Prentice Hall. And basically I'm going to create a data output stream. I'm going to write, let's say, the name of the book and the quantity or something like that, and I'm going to close the connection. Of course, this is highly simplified, but people don't do this in this way. What kind of problems do you think are present if you write code like this in an actual application? So imagine that you are working for Amazon and you actually write something like this. What do you think are the main problems? Again, this is very naive code, I know. Anyone? So,
I got one. All right, how about modifiability?
Okay, let me just repeat the question. So the idea is that if you remember the scenario, basically you had, for instance, Amazon making a purchase to Prentice Hall, a bulk purchase, something like 10 books, 100 books, 1,000 books. And the question, what I'm stating, is that no one would write code like this. So you know that normally in your courses, basically you open a socket to somewhere and you follow some protocol to put some data there and get some data from there. And in many occasions, in terms of classes and even small systems, you actually write code like this. And what I'm saying is that, well, in the real world, you would not write something like this. It has problems. And some people at CMU were going to state some of the problems.
One problem I see is modifiability. So we don't have any control over what Prentice Hall does. So if they were to change their way of ordering books, then our application is going to have some problems.
Okay, so modifiability. The question is that if they change the format on how books are ordered, basically you are going to have a problem. But there's another problem in terms of modifiability. If you look at it, I'm actually encoding the address of where I'm going to connect in some kind of string. But even if you imagine that it's not in a string and it's actually in a resource file or something like that, or a configuration file, it's still a problem. Because if you look at a large organization, in many occasions, the place where the resources are allocated and the servers are allocated, it changes from place to place and from time to time. So another problem besides modifiability in this case is that resource localization is not transparent. What else do you see wrong in this example? Security. What's the problem with security?
You use normal streams to send data. They have protocols to see if the source is reliable.
Okay, so if I use a secure socket layer, in this case, would that be enough?
No, because they have forms.
You have to press the button, don't forget.
They have forms where where we need to what we need to use to do the authentication and to buy the books.
So what you mean is that, press the button again, I actually need some kind of security layer that allows me to authenticate with the server and for them to actually be sure that it's me who is talking with them. But if you think about what happens if I actually make a purchase and later on I deny that I actually made the purchase, it's a problem, right? So if you are dealing with large-scale systems in general, we also need to have mechanisms for non-repudiation, for instance. I should not be able to deny later on that I actually ordered something. What else is wrong? Something very, very basic.
I have no response from the server.
Click.
There is no response from the server.
Okay, what does that mean?
I'm not sure that the order was made.
Okay, that's an excellent point. So, in terms of reliability, this is really bad. What happens if the server crashes between the time I wrote the 10 books and the time the connection was closed? Well, actually the order could be sent to the server and the connection would be closed or the system would crash and I would not know if actually it took place or it didn't took place. So should I repeat the operation? Should I wait and stand still? When I'm dealing with large-scale systems, basically, I need to make things transactional in many occasions. I need to have reliability mechanisms. Okay? So some of the major problems, although there are a lot of problems in this example, is that, as I said, resource localization is not transparent. If they actually change the server where the service is hosted, well, I don't know about it and I have a problem. The data format that I'm using is not universal. Actually, in this example, I was using Java Object Serialization, which is good for transmitting data across the network, but when you actually make the invocation and the data is on the other side, it's not really a good way of representing data. What happens is, if I'm unable to open the connection, just I give up. What happens if the server crashes? So whenever I'm going to more enterprise kind of systems, especially backbone kind of systems, back office kind of systems, I need to take into account things like these, things like security, things like data representation, and so on. Some of the major problems that in general you face, and actually you are going to be facing some of these in the second and third assignment, is that the first one is regarding data and representation of data. What's the proper data model to actually represent data? And in many occasions you think about data models and you think about classes and you think about object-oriented programming, but that's just a data model for manipulating things inside of an application. In terms of enterprise systems, many times I need to have documents, the equivalent of documents that are stored and that are transferred to different things. So one of the things really crucial in enterprise application integration is basically mapping data from one data format to another data format and transformation of data. In many occasions, a very, very common operation is to do data enrichment, which means that I have a document and somehow I need to enrich that document with the information that is coming from a database or a place like that. The second problem that you have when you go to very large-scale systems, it's localization of services. Imagine that you are developing a system or an architecture where basically you need to use 10 different services. Imagine, for performing a purchase, you need to contact the shipping department, you need to contact the accounting department, you need to contact, let's say, the warehouse, and so on. And you know that in many occasions, all these departments, basically they have their own information systems, and the localization of services change places. My system should be designed and be prepared so that whenever someone changes the localization of a service, my application doesn't suffer with that. And what this means is that in general, I need to have mechanisms to federate services, okay? Having service federation. Another problem is time and synchronous. So you are very accustomed to opening a socket and performing something on a server, or performing a remote procedure call or a remote method invocation. But the biggest problem that you have with that approach is that an RPC model, a remote procedure call model, it's a synchronous model. What this means is that when I do the invocation, the other guy needs to be there, right? If it's not there, my system crashes. This means that actually the systems are very tightly coupled, right? And it's not a very robust way of developing large-scale systems. In general, when I move to large distributed systems, what I want to have is asynchronous and decoupled systems. What this means is that I want to have a model which is a little bit more like a mailing service. Whenever you send a letter to someone, you don't need that someone to be sitting at the desk when you send the letter. Basically, you go to the post office, you put the letter is routed until it reaches the destination, and when the guy receives it, basically he does something about it. And actually, if you think about it, come on, hurry up. And if you think about it, actually, if the guy is not sitting on the desk when the post office tries to deliver the letter, basically he gets a warning or something like that saying, you need to come back and actually collect the letter. The final thing that is very, very common, and it's also a topic of this course, is reliability and fault tolerance. So my system needs to behave properly when everything starts to crash, right? So I need to have mechanisms, transactions, things like write systems, load balancers, and so on, which basically enable me to create an IT infrastructure that survives basically crashes and problems. And again, this is something that we'll see in the course at a later time. We already seen this in general in terms of data representation. In an ideal world, everyone would use the same data model. That's not really realistic. So from a perspective of enterprise application integration, the most important thing is actually the data formats at the services interface. So imagine, at the informatics engineering department, we need to talk with the accounting service at the central services at the faculty. Basically, we need to have a very, very well-defined contract between the interfaces of these two organizations. And in general, in many occasions, there's even what's called a service level agreement regarding how this communication and how the service will be operated. But in general, in terms of data, the most important place where I need to standardize the way the systems communicate, from our perspective, it's set the boundaries of the system. And as I told you, nowadays most of the systems are using XML, and there are a number of organizations standardizing data schemas for different types of business. Again, feel free to interrupt me at any given time. In terms of time and synchrony, the most important thing that happens is that, in general, when I'm doing this, imagine in the core backbone of a bank, basically I abandon the RPC model, the remote procedure call model, and typically what I move to is to asynchronous kind of invocation, something called message-oriented middleware. What this means is that instead of having an RPC when I do a call in this process, the other process has to be active, and I have to wait until it returns. Basically, I move to a way where what I'm doing is actually sending a message to the process, and somehow there is a middleware that stores the messages and forwards the messages as needed. Actually, this is called the send and forget model. So if you think about an application, I have a process here which creates a message, and when I call the send method, actually the message is not being sent to the final destiny. Actually, the message is stored in something called stable storage. This can be a disk or a write system or something like that. And then basically the middleware tries to contact intermediate steps or the final step to actually try to deliver the message. And actually when the message gets to the final destination, which typically is stable storage, we'll see this in detail later on, this middleware actually tries to contact the application and deliver the message. If the application is not here, the message stays stored. If this machine is not available, the message stays here. And when I go from here to here, in general, I have a transaction. This means that either I was able to put the message in the system, in the middleware, or the message was not sent. Okay? So, two main concepts: send and forget. Whenever I send a message, is like sending a letter. Okay? And basically, the middleware, what it does is store and forward. So there may be routing across systems until the message gets to the final destination. Was there a question? No.
Maybe.
Okay.
Yeah. How susceptible is this model to replay attacks?
How acceptable is the model to?
Replay attacks, like someone sends a message and somebody else intercepts it and tries to send it again, typically a payment.
Mm-hmm. So again, what happens in terms of middleware in practical systems is that you can configure basically security policies. So you can say that for you to actually connect to the middleware, basically you have to be authenticated, and some users can only send some types of messages. But this varies a lot from system to system and from implementation to implementation. For instance, in JMS, Java Messaging System, you have a certain API and a certain way of doing this. If you are using, for instance, IBM message queues, you have a different mechanism. If you are using Microsoft message queues, which, by the way, is embedded in every single Microsoft operating system, again, you have a different authentication mechanism. So, in general, it's solved by authentication. Okay? But again, we have a full chapter just about message-oriented middleware. This is just for you to get the first idea of what happens. So, on the top of this slide, you have the normal RPC model where basically, imagine if I have two banks, basically I connect the socket to the other side, I get an acknowledge, I do something like deposit on a certain account a certain value, and basically I get a message back from the bank saying something like no error. So in the first case, I'm really doing a protocol for doing a message invocation, and I have several message invocations going on. The model in general, when you are using message-oriented middleware, is that you have something called message queues. Message queues is something where you put your messages, okay? And what you put in message queues, it's not method invocations. What you put in the message queues, it's actually documents, messages. So in this case, for instance, if I wanted to deposit $100 to John, I would put in the bank B message queue an XML file that would say, deposit, name John, amount 100. And what happens on bank B in this case is that they have an application, they have a server that collects this file and does some processing on the file. So, guys, you need to be here on time. Come on. So basically, instead of doing these invocations, you are actually processing documents inside of enterprise systems. So in general, one of the things that I do when I'm using these systems at an enterprise level is that I have end applications. In a service-oriented architecture, these are actually called services, and they represent, in general, kind of large-scale systems. These applications have endpoints. If my IT infrastructure is based on message queues, in general, those endpoints are connected to message queues. And what I'm doing is putting, messages in channels, okay? When I develop these kind of applications, the messages are routed across several channels, and basically the messages can be transformed until they reach other end applications. While this is happening, basically there are in general dashboards and mechanisms to monitor what's going on and to wait state of certain processes. If you look at the web and if you go to many seminars, you actually see a lot of people talking about BPM, business process monitoring. Actually, it can also be used as business process modeling, which is a different thing. But what it means is that it's a middleware that allows you to look at your organization and see what's happening in terms of processes and what's happening in terms of these messages. Some examples of this kind of middleware and systems. Many of you have heard about Microsoft BizTalk Server. It's very, very widely used. B WebLogic. B has been bought recently by Oracle, if I'm not mistaken. IBM WebSphere has support for this kind of thing. TIBCO is one of the leading suppliers of this kind of application server, Web Methods, Vitria, and so on and so forth. So there is a lot of offering in the market for actually creating this type of systems. So I sent you an email 2 or 3 days ago regarding a case study that is in the first chapter of the Enterprise Application Integration book, Enterprise Application Patterns book. Did you have a chance to read it? Can I ask someone to explain it? Probably not. Okay. Please try to do the readings before class. So, the interesting thing is that some years ago, there was some people that were working on enterprise systems. What they developed was a pattern language for the kind of operations that you normally need to do in an enterprise application integration scenario. And that's what I want to discuss a little bit to give you a flavor of the kind of things involved. So, the case study that is present in the book, it's called the Widget Gadget Corporation, and it's basically a company that sells widgets to people, gadgets, things like this mouse, which has a laser and a presenter and so on, or an iPhone, things like that. And actually, what happened with this company was that it actually has 2 suppliers. Basically, they get their products from the Widget Corporation and the Gadget Corporation, and actually they have an online store and they can sell the products to customers. Okay? They also work with a different company called the Shipping Corporation, which is actually the shipping company that transports the products to the client whenever someone makes a purchase. And if you look at the organization in a little bit more detail, this is actually quite a large corporation, and they have several internal departments, people that operate on their own. So, for instance, they have these guys that take care of the billing and accounting, and they are in a certain office and they have their own information system, and they spend whole day doing some things on this very vertical information system. They actually have a shipping department, which are the guys that are responsible for sending products to the customers. And they also have an interesting situation, because since they actually bought these 2 companies and they work with these 2 companies, actually they have an inventory for the Widget Corporation and an inventory for the Gadget Corporation. The inventory is basically the guys that know how many units of a certain thing is available for every single product of widget and gadget. And they haven't yet restructured the company, which means they actually have 2 separate departments. The other thing that they have is a catalog for widgets and gadgets. And actually the catalog basically lists everything that the company has, independently of it being in inventory at the warehouse or not. Besides that, they also have this situation where they have to talk to customers because they are selling stuff, right? And for that, they have several options of taking purchase orders. So nowadays, everyone has a website, so they have a website where people can actually put orders. But they are kind of old-fashioned, and people can also call to them and say, I want to buy the item 1, 2, 3, 4. So they also have a call center, okay? And people also can buy things by sending a fax to them with the order and the credit card and so on. So they can also receive inbound faxes. And the other thing that they have is that from time to time, they actually send the catalog to clients, and they actually send them some promotion materials. So they actually send some inbound emails. I know that this picture is not really good because it's mixing departments with communication channels with clients. But again, this is basically a copy-paste from the book, so please bear with me. So in terms of business processes, what can people do? Basically, you can have the customers making orders, which means that they have to take orders, and these orders can be by web, phone, or fax. They actually have to process orders, and this includes verifying if you have the product in inventory, to ship the product, and actually sending him an invoice. An invoice is basically a bill saying you have to pay this. Customers can check the status of an order at any given time, and they also can do things like changing their address. There are new catalogs, so the catalogs have to be updated. There are announcements which correspond to email. And of course, the business people want to make sure that everything is going on okay. So you need to have ways of testing and monitoring the system. What I'm going to discuss, just for you to take an idea of what's involved, is just the taking of orders, the processing of orders, and the checking of status. So if you imagine that these are separate departments in a large organization, and that each department has its own information system that operates autonomously or semi-autonomously from the others, actually what you can decide to do is actually creating channels and message queues that allow to basically do business processes like taking orders. So how can this look like? So imagine that you need to create an order, okay? So you have a channel, a message queue, which can be called new order. And in this new order, basically you want to have a document, a message, which contains the detail of a purchase order. But if you think about the incoming messages may be different from channel to channel. So for instance, in the web interface channel, you may be asking the email of the client, but maybe on the inbound fax, you cannot really expect to have the email of the client, right? Or if you have the call center, it's very likely that you need to have a phone number to call the client back, but probably you don't need to have an email. And somehow you want to transform this diverse information into something that is unified. And what this means is that when you design your business process, basically from each one of these client applications, of these end applications, which have their own endpoints, you are going to inject the messages in specific channels. So imagine you can have a channel where basically you get an order from the web interface. You can have a channel or a message queue for the call center and a message queue for the inbound fax. But now you need to harmonize the information to the same data model. And for this you use a component which is called a message translator. So a message translator is something that gets a message in a certain data format and transforms the information so that it conforms to a different data format. Okay? So at the end of this process, basically you have a purchase order unified on this channel. By the way, one-directional channels that connect one source to one destiny, are called point-to-point channels. Okay? Yeah.
What I didn't understand is that new order. It has all the information of the other orders, or it's a design.
In this case, in this particular case, probably it would have all the information of all the of the data sets. But again, this depends from implementation scenario to implementation scenario. So imagine that this guy actually stores the original order and only puts here on this channel the information needed to actually ship that purchase. In that case, the information would not be complete to this side, because on this side you do not need, for instance, the email or the phone number or something like that. So in this particular example, it's the whole information, but in a real system it may be more information or less information.
So, if it's all the information, if you change something on the web new order, maybe you have to change all the message translators.
Mm-hmm.
So you're not gaining anything from...
Again, it really depends. So when you design the data models, you should try to have the data models to be resistant to small changes. What you are saying is true, but again, it depends on how you model the data that you are putting in the system. In general, if you are working at the boundaries, you should try to make the boundaries the most resistant as possible. I can give you an example. In my project with the European Space Agency, one of the first things that we design is the interface control document. And the interface control document says, these are the inbound and outbound interfaces for the system, and the design is yours, but you cannot change the interfaces. So you have to be really, really careful about how you design the interfaces of your system and how you design the data in that part, okay? Because that's your bounding contract, okay?
I have a question.
Okay.
How does this model represents only one order? Is it susceptible to change for different orders, like a multi-threaded application or something?
Can you repeat the question again? So how different is the
model if multiple orders are to be represented?
Okay, that's something that we'll cover in just one moment.
Okay.
Okay? I'm going to answer that in a moment because I have a slide exactly about that. Okay?
Yeah.
Okay, so imagine we have a purchase order at this point, right? So let's imagine what I have to do to actually send the order to the client, the goods to the client. The first thing is that I need to check if the item is in the inventory or not, because, well, it may be in the catalog, but I don't have any in my warehouse, so I need to check that. And at the same time, I need to check if the client has money or not. If the client's standing, it's credit, it's good with me. And this is something that can happen at the same time, actually. The other thing is that if actually I have the goods and the client has credit, I need to ship the goods. And for doing that, basically I have to contact the shipping company, shipping the goods, and at the same time I need to send him the invoice, right? Either with the goods or by letter or something like that. And this is what's called a business process. So I'm defining in terms of my business, it's not even in terms of code, it's in terms of my business what processing an order is, okay? So in terms of channels and exchanging of data, how could this happen? So if you look at it, you see that in this particular case, the checking of the inventory and the validation of the customer standing, they can happen at the same time. So one of the things that I can do is that I can create what's called a publisher-subscriber channel, which means that every single message that is sent to this channel is actually given to all the subscribers of the channel. So imagine, how do I check the standing of a client, if he has money or not? I need to contact the billing and accounting department. How do I check if I have the goods? I need to contact the inventory. So if I have a publisher-subscriber channel here, and these two guys subscribe the channel, what's going to happen is that every time the message is put here, it's duplicated and sent to these two guys, okay? Now imagine that each one of these guys generates a message. So the billing department tells me, this guy is good, he has money. And the inventory generates a message saying, this guy has, we have the product, we can actually ship it. So again, if I have a publisher-subscriber, a point-to-point channel, I will get two messages corresponding to the same order in this channel. So what do I need to do? I have two messages regarding the same order. What I need to do is to aggregate the information, right? And that's called an aggregator. Again, it's one of the patterns of enterprise application integration. Many times you have several messages that you need to combine into one, okay? In terms of middleware, it depends on the middleware, but this could be a component that you drag and drop in a development environment. Carlos.
Can you give more detail about the aggregator? Because I'm thinking, for example, if this aggregator opens a process for each two pair of messages, mm-hmm. and he could, after a while, you could have millions of processes mm-hmm. around. Or on the other side, if you only open a process when you have two messages, then you can have a lot of messages.
Okay. So when I'm saying business processes and processes, in this context is not operating system processes, okay? So in terms of middleware, this may be just a multi-threaded application server. And actually what this guy is doing is that if he knows that it has to correlate two messages, it's looking at the message queue and it has a trigger where basically whenever he sees two messages with the same ID, it combines them, okay? But that's at the implementation level. So again, at the implementation level, you can imagine that this can be like a producer-consumer application, and the consumer is basically a thread that is blocked, and whenever a new message arrives, basically a semaphore is signaled, the guy wakes up, and then he can check if that message corresponds to something it was waiting or not, okay? But again, that's really at the implementation level, okay? You don't have to implement this. This is implemented for you in general, okay? Okay, the other thing is that if you look at this diagram, you see that basically you can only send the goods and and send the invoice if you actually have these two things valid, okay? If not, you can basically generate an exception and send the client a message saying you don't have money or we don't have the product. How can you do that? That's another component called the content-based router. What this does is that given a message and a triggering condition, it routes the message according to the condition that is satisfied. So imagine that in the message that you aggregated, you say that you have the goods and you have the money. In this case, you could send it to a validated order channel. Imagine if one of them fails, basically you would send it to an invalid order channel, okay? So, again, if you look at this scheme, you have two actions to perform: sending the goods and sending the invoice. But you remember that this is handled by two different departments, right? So what do? Basically, you can have a publisher-subscriber channel again for the orders that are in a good condition, and basically the shipping department would subscribe to this channel, and the billing and accounting department, which is responsible for the invoice, would also subscribe it. Okay. I know it's getting a little bit tricky. So let's look at this in a little bit more detail, because I've represented this inventory like a white box, but this doesn't correspond to any kind of technology, right? So what does it mean to check the inventory, actually? So you remember that we have, in this company, two different types of inventory. We have the widgets inventory, and we have the gadgets inventory. So what do I need to do? I need to put a content router, and if it's a purchase order for a widget, basically I need to go to the widget inventory. If it's an order for a gadget, basically the message needs to be routed to the gadget inventory. But remember, this company and this company are companies that were just bought, and their information systems can be completely different. And the type of messages that they understand may have nothing to do one with another, which means that somehow I need to transform the message, the incoming message regarding checking the inventory, into something that this guy understands. And in the case of the gadget, the same thing. So I need to have message translators between this point and this point. Okay? Okay, coming back to the question of, I don't know her name, but...
Aparna.
Okay. Regarding... That's a strange name for us.
You call her Jill.
How does that correspond?
Okay, so imagine that we have more than one order, okay? So I need to check actually if I have different types of orders, like several widgets and several gadgets, and I need to check, for instance, if they are in the inventory. How can I do this? For doing this, I use a component which is called a splitter, okay? So what this component does is basically, given a single message, it breaks the message into several messages according to some kind of criteria, okay? So imagine, I have an order, it has 3 products to be ordered, I have to check if the 3 products are available or not. I can split this in 3 messages, And again, basically, I can do content routing based on the content to each one of the inventory sections. You will see that there's a new thing here. It's called an invalid order item. This is very, very common. So, in many occasions, I want to develop robust systems. And what this means is that I cannot really crash if I don't understand a message or I don't know what to do with the message. And remember that we are not doing method invocation. We are really designing messages, XML documents that represent something. So in this type of systems, it's very, very common to have a channel where I can put messages that I don't understand. And every time a message is put here, basically it can be checked by a system administrator and he can decide what to do. Okay? In real systems, and this is something that you should take into account, in real working systems, there are tough decisions that many times cannot be taken by the system because the system doesn't know what to do. Okay? And in those cases, human intervention is needed. Let me give you a funny example, or an example. I don't know if it's funny or not, but it's an example. When I was a student here at the university, many times I would run out of money. And I'm sure that happens to at least some of you. So I'm not from this city, so I didn't have money and I needed to eat on the following day. So how did I solve, in general, the problem? You know that if you go to an ATM machine and you don't have money, you don't get any money, right? It depends. That's right. Actually, if you go to an ATM machine at midnight or between midnight and 2 a.m. and you put your card in, actually you can get some money up to some limit, something like 50 euros, 100 euros. Okay? And the reason why this happens is that the machines are taken outside of the main system for maintenance, and basically the machine will record that you took the money and it will settle the account when it's connected again. But what this means is that your account actually can go below zero and you have to pay interest and so on. Now, the funny thing is that my father was actually a bank manager in the bank where I had the account. And whenever an account bounces, which means it goes below zero, the manager of the bank at the end of the day has to sign a paper. He gets a paper that says, these accounts have bounced and you are doing something about it. Because the computer doesn't know how to get the money from the people. So what they normally do is actually phone the person and say, your account has bounced, you don't have any money. What are you going to do? You should put some money there. Okay, in the case of my father, what he would do would be to put some money in the account and say, what are you doing? Are you spending all my money? The point I'm making is that in real systems, many times there are some things that the system is not able to handle. And in enterprise application systems, you should design the system so that when it gets too complicated for the system to handle or too tricky or too political, you should have a mechanism that allows a human to actually intervene. So it's very, very common to have these invalid order channels or dead letter channels in this type of systems. Okay?
Paulo, a question. Yeah. So about sort of managing the consistency of the overall interaction or transactions or whatnot. So the kind of situation I'm thinking of is what happens if you have a problem, you have an invoice, an order that has, let's say, 3 items on it. Some of them come from the widget, some of them come from the gadget. After it splits, you have a problem with the message on one side. but you've now split this into multi-channels. You have something going off to invoice. You have multiple channels going to different inventories. How is it that you understand that the overall transaction is completed, and you know what to invoice for and that kind of thing?
Okay, that's really one of the tough things. So, if you look at this is getting really messy really quickly, right? And what happens, and this is something that we'll discuss in detail in the chapter that deals with this kind of middleware, is that if you have completely distributed processing like what I'm illustrating here, it's very easy to lose control of the system, and after a while no one knows what's going on, and you start to have a lot of problems. I can tell you that I've done some consulting for a telecom in Portugal, and this is actually one of the problems that sometimes they face, because they deploy systems, they interconnect the systems, but there is no global view regarding what's going on. So sometimes people talk about the service-oriented architecture and say, this is going to be completely decentralized and I can just connect some services and so on and it's going to be great. It's not so, and you should be really, really careful about it. The way it's solved, and again, that's something that we'll discuss in a moment, is by using what's called a process orchestrator. So what you do is not really to connect this in a completely distributed fashion. You actually have the queues between the different information systems, but actually you have something called the process orchestrator. And the process orchestrator is basically an application server where you deploy a file that looks a little bit like this and actually represents the runtime system in a sense. Connected to this, in general, you have what I was telling you about called a BPM engine, a business process monitoring engine, which basically allows you to track if a process is going well or not, or if a process is stopped by some reason, okay? And in many occasions, you can actually have triggers associated with certain steps saying that this step cannot take more than this time or an alarm is raised, okay? But again, that's really a key point. If you try to do it in a completely distributed fashion, it doesn't scale. It's really a problem.
A quick follow-up question to that,
okay.
Paulo. So is this facilitator a typical bottleneck or a limiting factor for scaling a system?
Yeah,
the orchestrator?
Mm-hmm. It is. Because it looks a lot like what's called the hub and spoke architecture. So basically you have this, in general, it's a single point of failure, and at the same time, it's really a performance constrainer because all the processes, all the business processes are being run by this application server. What happens in terms of more industrial kind of systems is that these application servers, they tend to be designed so that it allows for horizontal scalability, which means that many times it supports things like clustering, and you can put more than one machine and one instance running, and that's something that is normally supported. But it's really a constraint in terms of performance in general. Okay?
One question. I have one question. You said that the facilitator would be the single point of failure. So does that mean that there was a handling exception component in the activity diagram? So all exceptions are being handled by this facilitator, or it can be done locally to make it better? Okay,
so we'll have a chapter just about this. What happens is that these message queues, in general, are transactional. And what this means is that a message either is at QA or is at QB. So the main criteria is that you don't lose messages. and at the same time, you have what's called stable storage associated to each message queue. Stable storage, the concept of stable storage is the following. If you have the definition of a fault model, which means that my system can fail in this way, for instance, my disk can crash, or I can have a fire in a building or something like that. So you define a failure model, and basically you design a storage system that is able to tolerate that failure model. And that concept is called stable storage. So what happens is that you do each one of these message queues transactional, and actually the process orchestrator that I was talking about always stores the state of the process in a database, again in stable storage, whenever there is a transaction between states. Okay? And that's why it can, when it recovers, it can go back and start to process again. Okay? There was another question?
Yeah, it's also regarding exceptions. But it's kind of in the same context that she said. If a new order passes the routing and an exception occurs afterwards, can we roll back and send it to the invalid order item?
In general, as I said, these message queues are transactional, which means that if the system is well designed, if you get an exception, by whatever reason, the system should roll back to the previous point. And again, when you have problems, supposedly the BPM software should raise an alarm if that happens. Okay? Again, this is the theory. In practice, it gets really complicated really quickly. Okay? Okay. So, what I've told you, what I've shown you is that this white box that I had here, which was the inventory, is actually something that is composed, okay? I have something inside which is much more detailed. And many of these type of systems actually allow you to design the system at different levels. So this check inventory is actually a component in the system, and this is called a composed message processor, because what I'm doing is going inside, splitting messages, routing them, aggregating again, and this looks like just a box, but it's actually something I can double-click, go in, and adapt and change in terms of processes. Okay? Okay. But there's something that I haven't told you yet. If you look at the splitter and the aggregator, I have to have a way when I aggregate the data again to know that it refers to the same order. But I haven't yet created an identifier to the order, right? So one of the things that I need to do in general is adding identifiers to messages. So imagine that you have an order coming in. This order needs to have a unique ID, right? So basically, if I have an XML document at this end, I need to edit a unique ID, or I need to add information about the owner of the order and so on. And that process is called a date enricher. So basically, you get a message, and you want to enrich that message with more data, okay? So it's, again, one of these patterns that you have to follow. I'm running out of battery. Sorry, guys. Okay. Okay. Going back to Matt's question, how do I know the state of a certain order? How do I know if everything is going on okay or not? In general, I need to record somewhere what's going on in terms of messages. So if I just want to record or to save somewhere in which state the messages are going on, so that later on my BPM software is able to make sense of it. If I just have publisher-subscriber channels, that's really easy. The only thing that I have to do is to put a data store and have it subscribe the publisher-subscriber channel. If I actually have point-to-point channels, then I use a component or a pattern called a wiretap. A wiretap is basically something that monitors a channel and makes a copy of every single message that is passing the system. And again, I could connect this wiretap basically to my message store again. Okay, so what I'm telling you, and the point I was making, is that in general you are not going to do this thing completely distributed, because some of these channels are real, like the message queues between the different departments are real, but some of the things are actually logical channels, and they don't need to be physical channels, because they can represent just state transitions in a process, a business process, right? So in reality, in these systems, what I have is what's called a process manager. And in a process manager, basically I define all these interactions, and basically I deploy the process into an application server. And this process is basically what's keeping track of all messages and everything that is taking place. Okay? Carlos?
So that process manager is where you keep the business rules, right?
Exactly. It's more than business rules. It's actually the business process. So it's a set of diagrams. Let's say that for any given process that was initiated, like a purchase process, it keeps an instance for every client or for every process taking place. Okay? In general, for it to be scalable, what happens is that the processes are not running at the same time, because some of these things can take minutes, hours, or weeks. So in actual application servers, what you will see is that you have a database, and whenever there is a new event, basically the application server takes the state of that process out of the database. It performs the necessary transactions, and after a certain while, basically, it sends the process, it serializes the data of that process again to the database. And that way, imagine if you have 100 or 500 people making a purchase at the same time, you are not keeping in memory all that data at the same time. It would not scale. Okay? What you pay in terms of trade-off is that it's slower than just keeping everything in memory.
Not only that, if you change the business rules in between.
That's really a tough problem. So, again, going to the telecom operator that I was telling you about, one of the biggest problems that they had was that, you know, if you are installing a telephone line to someone, or if you are doing if you are installing a telephone line to someone, or if you are doing imagine that you are trying to get money from someone who didn't pay or something like that, you actually have a business process, right? But business processes change over time. Now imagine what happens if the way you do business changes, which means that you update the business process, but you have a process that takes 1 week to execute still going on because it's waiting for a phone call from someone, or it's waiting for the guys to actually go installing the line to the house of someone. It's really a problem. So what happens is that in general, in real systems, you need to support versioning on these guys, which means that you need to know not only what processes are executing, but each instance is associated to a version of the business processes. And again, in the case of this telecom operator, which I guess you know which one it is, one of the problems that they have was actually versioning of business processes. Okay? Is that a question? No. Okay.
The process manager is only one process or more than one?
Again, in general, you cannot do it just with one machine and one instance. So in general, what happens is that this type of application servers support what's called horizontal scalability. What this means is that you can put a cluster, you can configure the addresses, and basically it acts as a single machine, although it's several machines at the same time. Okay? Of course, there is a lot of plumbing going on for it to happen properly, because imagine, you need to have network transparency, which means that you cannot keep the state just in one machine. You have to have something like shared storage and things like that in a storage area network or something alike. Okay? Okay, so giving you some pointers to the next class, what we are creating here is basically what's called an enterprise service bus. What's an enterprise service bus? These are departments that are autonomous in a way. They have their own vertical enterprise, they have their own vertical information systems, and you are defining very strict contracts about what's going in and out of these systems, right? And basically you are publishing all the services in a virtual bus. So a bus is, a communication channel or a set of communication channels where things are present. Imagine in your computer, all the cards are in a PCI bus, right? Which means that you can communicate with each one of the cards. In this case, what you are doing is creating these interfaces that are well defined, and you are making them available to your whole enterprise. And this concept, very roughly, it's called an enterprise service bus. When you create a service-oriented architecture, in general, you go one step further beyond this. So in a service-oriented architecture, and again, the definition varies from author to author, what you have is basically an enterprise service bus, something like this, a process orchestrator, a place where you actually assemble several services and orchestrate them to actually achieve some business goal, and this is actually called the business process. And in general, what you do is to publish both the description and the location of each one of these services in what's called a service directory. So whenever you need to create a service or use a service, you go to the service directory, you get the actual specification of the interface and the location of the actual service, and only then you execute the service. Okay? So roughly, what I'm telling you is that a service-oriented architecture, in a nutshell, looks a little bit like this. You have autonomous independent systems, which means that in general these systems operate independently of each other, and they perform some business role, and they have a service interface. They have an integration interface. And this integration interface, which represents business functions, is available throughout the enterprise for you to use. Again, giving you the example of our department and our university, this guy here, the first system could be the accounting service at the faculty. This guy here could be the academical services that take care of your grades. This guy here could be the classes repository in our department. This guy here could be the project notification guys in our department, and so on. And each one of these publishes a contract in a very well-known place. And this contract includes what kind of functions they have available, what kind of services they have available, and the current location of the physical infrastructure where it's running. What you do then, in general, is to have a process orchestrator. And what you do in the process orchestrator is actually deploy business process files which contain the description of a business process that uses several of these systems. Again, bear in mind that this is one definition of a service-oriented architecture. There are several definitions of it. One thing that is not a service-oriented architecture is something that is just web services, okay? Web services, it's just a communication technology. If you put system A calling directly system B using web services, and system B is calling directly system D using web services, and D is calling A and B using web services, that's not a service-oriented architecture. Actually, that's crap. That's what's called point-to-point integration, okay? And it's a nightmare to maintain, because after a short while, absolutely no one knows what's calling what at any given place. It's like Leslie Lamport used to say, a distributed system is when a machine that you don't know it exists makes your system crash, okay? We don't want that kind of things. To give you an example, this is a very, well, it's an old image, but when you are defining business processes, you have some kind of IDE, and basically you are specifying what kind of invocations happen and when they happen, and what kind of systems should be contacted. In this case, it's actually a sample from Oasis, that standardization organization that I told you, and this is being done in a language called Beeple, which we'll see later on in the course, inside of Eclipse. Okay? Okay. Any questions? No questions. Good. Legacy systems. You know, when you start to actually work and going to an enterprise, you cannot just start from the beginning. Even very small enterprises have a number of processes and applications and things already running, working, supporting the business. So you have a problem. And this is a problem that we'll discuss in detail in some weeks. But the problem is that how can you design something like this when actually everything that you have is point-to-point integration in an enterprise? It's a problem. That's called integration of legacy systems. And there are ways of doing that. One of the ways that you can integrate very vertical systems, especially when they don't give you integration interfaces, it's by using what's called a small proxy. And let me explain the problem. The problem is that, imagine that you have a very old accounting system, okay? And the way you access this accounting system is through a very old terminal, a VT100 or something like that, which is basically a screen, and it basically supports one user. So you need to do some screen scrapping, and if you need to do something on the accounting system, you actually have to send him some keystrokes or something like that. So you have a problem, because imagine that you have messages and you have processes asking things from this accounting system. if you are actually, let's say, introducing a new user or getting information for that user, you cannot really be doing everything at the same time. So you need to put some kind of software here, which basically gets the messages and somehow order them and performs one operation at a time. Okay? You need to have some kind of interfaces here. But then you have another problem, which is when the system responds, basically you need to know where to send the message. So somehow you need to keep track of who is asking for what and generating the corresponding message to the corresponding requester, okay? And this type of component where you are actually correlating messages that were sent to you and you are generating new messages that have a particular destiny, it's called a smart proxy, okay? Again, this is something that we'll see in more detail when we cover legacy systems. Remember, this class is called Enterprise Application Integration in 2 hours. Okay, so I'm just trying to show you the kind of challenges that you have when you actually design these kind of systems. Okay, some important points regarding this whole example. First of all, if I'm dealing with large-scale systems which are autonomous, they have their own life and people are using them, they are quite vertical, what they have in general is integration interfaces. So an interface that was thought for the system to integrate with different systems. But when I have that, in general, I cannot rely on a synchronous model. Some systems are designed that way, but in general, that's quite dangerous. In general, what I do is basically try to design a system that is robust and asynchronous, a system that doesn't depend on having a response immediately. Okay? Legacy systems are typically interconnected using adapters. Adapters can either be wrappers that encapsulate the whole system, or they can be things like smart proxies that basically translate from one place to another. If you look at this example, the most recurring theme is that I have messages circulating. And all these messages have to be translated, enriched, filtered, duplicated, and so on. So if you look at the message, it's a little bit like it's growing, it's shrinking, it's changing, it's being duplicated, and so on. And what I've been discussing today, it's the kind of patterns that you normally have. An enterprise service bus is that when I have my silos, when I have my applications, and I define a very strict business interface, so the business functions that my silo offers, and I publish these in a bus using some kind of middleware where other people can use it. And this is an approach transversal to the organization. So over time, all my services are being very lightweight, a very light description is when I have an enterprise service bus and actually I have the service description and interface published somewhere in a directory service. In general, I'm using open standards because I want these to last over time. And in general, I have a process orchestrator where basically I can combine the different services in a way that I understand what's going on and that I can evolve them. There's middleware for all of these. There's middleware for message exchange, things like IBM message queues, Microsoft message queues, things like JMS and so on. And there's also middleware and application servers available for process orchestration. Things like Microsoft BizTalk, web methods, and so on. Be careful. There's a lot of hype in the industry regarding this area. And actually, if you look at things like Beeple, everyone says, I want to use Beeple and so on, which is a language and a way of doing process orchestration. Well, Beeple, although it's used and it's important, it's really crappy. So don't pay too much attention to hype. What you have to think is, how can I design a system that lasts long? And how can I design it so that it's robust? And so how can I design it so that over time I can continue to integrate new services and I can maintain my process orchestration and so on, okay? So what I'm telling you is that it's fine to use web services, it's fine to use Beeple, but again, at the end of the day, what you need to have is to have a system working. It's not to have technology A, B, or C, okay? So be careful about that, because many technologies out there, they are really crappy regarding this. So, what have we seen today? Very briefly, in 2 hours, less than 2 hours. We've looked a little bit on how data is represented. And one of the key points is that I always need to have mapping and transformation primitives. We've discussed a little bit about localization of services. Again, think about a large organization and think about how the servers change from IP to IP and from address to address. In general, I should have things like federation of services and service directories that list where actually the running instances are. We looked a little bit to time and synchronicity, and the main lesson or the main message that I want to pass is that in general it's much more easier to design a robust system if you use an asynchronous model than design a robust system if you use an RPC model. RPC models, from a fault tolerance point of view, are really bad, are really difficult to design, okay? Finally, in terms of fault tolerance and IT, in general, I need to have appropriate mechanisms. For instance, in terms of the message queues, in general, the message queues are transactional. In general, I use things like stable storage and so on and so forth, okay? These are some of the concerns designing enterprise systems. Some other things that we'll see during class are things like integration of legacy systems, security concerns, the actually protocols that regard asynchronicity and fault tolerance, and the like. Okay? A very useful reading. I advise everyone to actually take a good look at this book. The book is not fully available online, but it's in our library, and there's a copy at CMU also. And although in practice many application servers don't have all those primitives in a very nicely packaged component, actually the patterns that they describe, the data enrichers, the message translators, and so on, the patterns remain constant. And they have remained constant for the past 10, 50 years. So if you read it, you get the language that everyone uses when designing this kind of system. And it's actually a nice book to read. It's very well written. Questions? No questions?
The site doesn't.
Matt, any questions on your side?
Doesn't look like it.
Okay, guys. So that's it for today. And yeah. Can you?
Next week's class is at 2. It's a little bit early.
It's at 2, but it's only 1 hour. Okay?
It's here?
it's here. Okay? See you guys.
Thank you.